Hello everyone, welcome you all again to my video series. This video is particularly about the subject Physical and Analytical Chemistry from the SYB.sc course. So in this video we will again discuss about the numericals from the chapter of physical chemistry, that is chemical kinetics. So in last video we are discussing about the numericals from the energy of activation. We discussed the formula, that is EA is equals to 2.303 into R T2 into T1 divided by T2 minus T1 into log of K2 divided by K1. There is one more formula related to exponential form of Arrhenius equation. From this formula also we can calculate the energy of activation by using frequency factor. So K is equals to A into E raised to minus EA upon RT. Then second type is related to order of reaction. So in order of reaction there are two different formulas related to half-life period and initial concentration is given, and second formula is related to rate of the reaction and concentration is given. So these are the different formulas related to chemical kinetics. We will see by discussing some numerical. For a gaseous reaction, 2HI gives H2 plus I2. The half-life period are 40 hours and 10 hours when the initial concentration of hydrogen iodide are 5 mole liter inverse and 20 mole liter inverse respectively. Calculate the order of reaction. So this numerical is related to calculating the order of reaction when half-life period and initial concentration is given. So firstly we will write the given things. So here half-life period is given, that is symbolized as an T half. So T half of 1 is equals to 40 hour, T half of 2 is equals to 10 hour. Then there is a initial concentration. So initial concentration is symbolized as an small a. So A1 is equals to 5 mole liter inverse and A2 is equals to 20 mole liter inverse. So we all know the formula for calculating the order of reaction when half-life period is given, that is N is equals to 1 plus log of T half of 1 minus log of T half of 2 divided by log of A2 minus A1. So simply we have to substitute this value in this formula. But while calculating the things of order of reaction, firstly we calculate this fractional term, and this term we have to add in this one for simplicity. So here T half of 1 is equals to 40, T half of 2 is equals to 10, A2 is equals to 20, A1 is equals to 5. So we have to calculate their log. Log of 40 is 1.6020, log of 10 1, log of 20 is 1.3010, and log of 5 is equals to 0.6990. So when we divide this whole term we get the answer 1. So 1 plus 1 is equals to 2. So finally we get the answer, the order of reaction is equals to 2. Then again we will see one more numerical. The second order rate constant for a reaction between pyridine and pyridine and the methyl iodide in benzene solution at 60 degrees Celsius is 1.46 into 10 to the power minus 4 liter mole inverse second inverse, and energy of activation is 14.3 kilocalorie mole inverse. Calculate the frequency factor A of the reaction when R is equals to 1.987 calorie degree inverse mole inverse. So in this numerical we have to calculate the frequency factor, that is your term A. So frequency factor is related to the exponential form of Arrhenius equation. So firstly we will write again the given things. So here R is given, that is gas constant 1.987 calorie degree inverse mole inverse. K is given, that is the rate constant is 1.46 into 10 to the power minus 4. Then energy of activation is given, that is 14.3. And also temperature is given, that is 60 degrees Celsius. So firstly we convert this in Kelvin, that is 333 Kelvin. But here one important point to be remembered, that R is given in calorie degree inverse mole inverse and energy of activation is given in kilocalorie mole inverse. So their units are different. So firstly we have to convert this energy of activation into calorie degree inverse mole inverse. So for converting we have to multiply this by 1000. So 14.3 into 1000 is equals to 14300 calorie degree inverse mole inverse. So this is the important point. Then by using the formula, that is K is equals to A into E raised to minus EA upon RT. So K is given, that is 1.46 into 10 to the power minus 4. A, that we have to calculate. E we have to take as it is. EA is equals to minus 14300. R is equals to 1.987 and T is equals to 333. So we have to first calculate this bracket. So while calculating minus 14300 divided by 661.7. So when we divide this both terms, we get the answer, that is 21.611 when we divide this two factor, and we have to take their exponential form. So while taking exponential form in calculator, we have to first press this shift and then we have to press that, first press this shift and then we have to press this ln, then we get the E. Then we have to take bracket minus 21.611 bracket complete. Then we get the answer, that is 4.1158 into 10 to the power minus 10. So that is our exponential form. Then we, while calculating A, that is frequency factor, we have to divide this term to K, that is the rate constant, and when we divide, we get the answer 354799.5. We can also convert this answer in or round of this figure, that is 3.55 into 10 to the power 5 liter mole inverse second inverse. So this is our final answer, that is a frequency factor, and their unit is most important, that is liter mole inverse second inverse. So here our numerical is completed. Thank you.